Here I have two vectors a and b, and I want to add them together so that we get some resultant vector c. In other words, what I'm trying to do is a plus b equals c. Now, graphically what we would do is we would take a and we would put the tail of b on the tip of a, and the resultant c would be from the tail of a to the tip of b. But how do we do that? Well, a vector is completely defined by a magnitude and a direction. So notice the magnitude of a here is 2.5 centimeters at some direction theta a, and the magnitude of b is 5 centimeters in some direction theta b. As long as I don't change the magnitude or the direction of either vector, I haven't changed what either one of those vectors is. So what I can do for a is I can take a ruler and I can just go along this ruler anywhere I want on the page, and as long as I draw it to be 2.5 centimeters in that same direction, it won't change the vector a. So let's do that right now. There we go. There's vector a, somewhere different on the page. Now, what we can do for b is put the ruler, oh no, see that's no good. That's not going to get us anywhere near a. Well, in your geometry set from elementary school, you probably have a set square somewhere, or from high school, and you probably, I don't know, have used it very rarely in your life. Well, guess what? It's going to come in perfectly handy here. So if I take my ruler and I put my ruler along b, the beauty of the set square is that it has two orthogonal or perpendicular sides, 1, 2. So if I set my set square along my ruler, just like this, I now also have a perpendicular side. So this right here is now perpendicular to the vector b. If I come along that perpendicular and drag down along my ruler, I now have, oops, I went a little too far. Let's go back up just a bit. There we go. I now have a direction that is not orthogonal, but parallel to b. So right there, this line is now parallel to b, and as long as I make this the proper length, the 5 centimeters that b is, I'll have a perfectly replicated vector b. So let's see, 1, 4, 5. So right there, that's vector b. And the resultant vector now, from the tail of a to the tip of b, is the resultant vector c. You can think of these as displacement vectors, so think about an initial displacement a plus a second displacement of b. Where do you end up? Well, your net displacement or your resultant displacement vector c represents the exact same motion.